In this video, we're going to solve a variety of log and exponential equations. Okay, so you'll see part 2 a lot of times. So we did one type in the log and exponential sections, but some of them are harder and require a bit different technique where we have to use both the logs and the exponentials sometimes. So we're going to see all different types here. So the first one we're going to talk about is if we can write the equation so that we have log base b of something equals log base b of something else, then we can say that m has to equal n and solve that using whatever techniques. Okay, so I am going to do this easy one and leave the harder one for you to do, but I'll do one of those type later. So here, so I want to write it so that it's log of something in the same base equals log of something else. So right now I have this 2 is bugging me. So what I can do is move that 2 up to the power. Okay, so I'm using that rule in the opposite way. So that means log base 2 of x squared, sorry, not base 2, base 5. Log base 5 of x squared is equal to log base 5 of 9. And now I have the same base. So I have log of one thing equal to log of other thing where the bases are the same. So I can conclude that the insides need to be equal. So that means x squared has to equal 9, which means that x has to equal plus or minus root 9, which is 3. Now I want to check our answers to make sure that they work. So if x is 3, then I have 2 times log base 5 of 3 is equal to log base 5 of 9. And that's true because I can move the 2 up. So log base 5 of 3 squared is equal to log base 5 of 9. Okay, that one works. But if I try to plug in x equals negative 3, then I have 2 times log base 5 of negative 3 equals log base 5 of 9. And log base 5 of negative 3 does not exist. So remember, you cannot have a negative inside a log of any base. Okay, so the negative 3 is an issue. So that means that we don't have the negative 3. So the only solution, the solution set, is just 3. Okay, so I can only have the positive version for my solution. Okay, now I'm going to leave number 2 for you to do. It's going to be very similar, except the solving part is going to be a little bit harder after. But you'd want to move this over to that side. So you have 2 logs. This 2, we're going to use the same trick we did above. And then you can set the insides to be equal. Okay. Now, technique number 2. So like we did in section 6.4, if we can rewrite the equation so that we just have one log equals some number, then we can convert to the exponential equation. So remember, I'm going to write the whole thing. Okay, so log base b of m equals n is the same as saying b to the power n equals m. Okay, so that's the exponential version. And then we can solve that. So I'm going to skip number 3 and do number 4 here. So I want to write this as a single log. So when I have a plus in between 2 logs with the same base, I can write that as a multiplication. So this is actually log base 6 of x plus 6 times x plus 2. And that's equal to 1. So now I have log of something equals something. So I can use the switch. So that's going to be 6 to the power 1 is equal to x plus 6 times x plus 2. Okay, so this is switch to exponential. Okay, and here we did write as 1 log. Okay, so we use the log rule. So now I just want to solve this. So I'm going to expand on the right-hand side. So that's going to give me x squared plus 2x plus 6x plus 12. And I'm going to move the 6 over and then combine these two terms. And that's going to give me 0 is equal to x squared plus 8x plus 6. So I'd want to factor this, which is not easy. So there's not two numbers that multiply to give 6 and add to give 8. So if I use the quadratic formula, x is going to be negative 8 plus or minus 8 squared minus 4 times a is 1 times c is 6 all over 2 times 1. So that's negative 8 plus or minus, so this is going to simplify to the square root of 40 over 2, which gives me, so negative 8 over 2 is negative 4. And then square root of 40 is square root of 4 times square root of 10. So that's going to be 2 square root 10 over 2. And then my 2's can cancel. So I get negative 4 plus or minus root 10, which is going to give me x equals negative 7.16 and negative 0.838. Okay, so those would be my two possible answers. And then we'd want to check, basically want to check that they're not negative when I plug them in. So if I check x equals negative, so approximately equal, negative 7.16, I'm going to have log base 6 of that number plus 6 plus log base 6 of that number plus 2, okay, equals 1. And both of these are negative. So that one is also negative. So that means they don't exist, so that's not a solution. Okay, but the other x value is also negative. But when we plug it in, when I add 6 or 2 to it, I get a positive number. So this is log base 6 of negative 0.838 plus 6 plus log base 6 of negative 0.838 plus 2 equals 1. And here, this number is positive and this number is positive, okay, which means it's going to work out. So this is a solution. So our solution is only x equals, so it's going to be, that's the positive version, so negative 4 plus root 10. If you use the exact answer and not the approximate one. So that would be our answer there. So that's another type. So now exponential equations. So if we had, so this is the technique number 1. So this is what we did in section 6.3. So if we could write it with the same base, okay, so if you can write with the same base, then you can set the exponents to be equal. So for example, if I have 5 to the negative x equals 25, I know that I can write 25 as 5 squared. So now that they're the same base, I know that negative x has to be 2, which means that x has to be negative 2. Okay, which, I mean, you can check that, but it's going to work out. Okay, so that would be our solution. But what if you only have a single exponential? Okay, so maybe I have some exponential equals some number. So what you can do is you want to isolate the exponential, okay, so that you get something looking like this. Then if it has base e or base 10, we can use the equivalent. So what they're talking about here is a to the m equals n is equivalent to log base a of n equals to m. So the reason why they're focused on base E and base 10 is that your calculator has buttons for those. Okay, so then you will be able to compute log base A of n if A is E or 10. If it's a different base, then what we can do is take the ln of both sides, the natural log, or the log, but we normally use natural log, and then simplify. Okay, so that's so I'm going to do the first two and then skip the next three for you to do. Okay, so let's do these two here. So the first one is base E, so we could just use the swap. Okay, so this is going to be log base E of 5 is equal to 2x, which is the same as saying ln of 5 is equal to 2x, which means that x is ln of 5 over 2. We divide by 2, and we can compute that on our calculator and know that it's approximately 0.8047. Okay, so that's the exact answer with the approximate answer. Okay, now for part number 7, my base, so my A value is 2. So that's not E or 10. So what I'm going to do is take the ln of both sides. So ln of 2 to the x plus 3 should be equal to ln of 3. Okay, now I can simplify by taking this x plus 3 and moving it to the front because it's the exponent. So that's a log rule. So then I have x plus 3 times ln of 2 should equal ln of 3. And I want to solve for x. So now I just expand this through. Okay, so it's x times ln 2, oops, not equals, sorry, plus 3 times ln 2 is equal to ln 3. Now 3 times ln 2, that's just a number. So I want to move it. It doesn't have an x. Okay, so I move it to the other side by subtracting. So that gives me x ln 2 is equal to ln 3 minus 3 ln 2. Again, this is just a number. And then I can divide both sides by ln of 2, which is a number. It's going to cancel on this side. And that's going to give me x equals ln 3 minus 3 ln 2 all over ln 2. Okay, which if you compute that is approximately negative 1.415. Okay, so that is our answer for this one. Now we don't have to worry about checking really because nothing bad can happen here. The domain for an exponential function is all real numbers. So this is always going to be a positive number, 2 to any power, and 3 was a positive number. So I don't have to worry about taking the ln of a negative number. So those are a couple examples. So you're going to try these 3. Remember, I'm just going to write a little note here. So it's remember to solve for the exponential first. So before you do what we did in example 6 or 7, you're going to want to get the exponential function on a side by itself. Okay, so just make sure you do that first. Now another type, what if our equation has 2 exponentials? So, and where they're different bases, where neither base can be written in terms of the other one. So something of the form a to the m equals b to the n. So then we can use the natural log again. So take the ln of both sides, bring the powers down, right? And then solve for whatever variable you want. Okay, so I'm going to do number 11 here. And then I'll leave number 12 for you to do. Okay, so I cannot write 12 as a power of 3. Okay, it's 3 times 4, but it's not a power of 3. So what I can do is take the ln of both sides. So this means that ln of 12 to the x minus 2 is equal to ln of the 3 to the 2x plus 4. Okay, and now I can bring the exponents down. So that's going to be x minus 2 times ln 12 equals 2x plus 4 times ln 3. Okay, now I want to solve for the x's, so I want all the x's on one side, which means I'm going to have to expand, okay, these brackets. So we're going to have lns everywhere. So I have x ln 12 minus 2 ln 12 is equal to 2x ln 3 plus 4 ln 3. So I want all the x's on one side and all the other things on the other side. So let's move the x's to the left by subtracting 2x ln 3. So that goes away. And I'm going to move the other things to the other side. So I'm going to add 2 ln 12 to both sides so that it cancels here. So that's going to give me x times ln 12 minus 2x times ln 3 is equal to 4 ln 3 plus 2 ln 12. Okay, and then I can factor out my x on the left. So then I have ln 12 minus 2 ln 3. And then I can just divide by that. So x is going to be 4 ln 3 plus 2 ln 12 over ln 12 minus 2 ln 3. Okay, now we could simplify this because 12 is 3 times 4, so we could break it up further, but there's no need. Okay, we can compute the number. This is approximately, so all of these are numbers, right? Ln of a number is a number. Ln of a positive number is a number, I should say. So this, if you calculate it, should be about 32.551. Okay, so that's our exact answer and our approximate answer. Okay, so I'm going to leave number 12 for you to try. Okay, now we could also have an exponential equation that we can write in quadratic form. Okay, so we did some of these without the exponentials, but we did quadratic form equations before. So basically you just want to write what your sort of u is, and then you're going to get, so let's let u be some exponential equation here, and then when I substitute it in, I get something that looks like a quadratic equation, which I know how to solve. And then we get multiple, sometimes, multiple exponential equations to solve. So I'm going to leave 13 for you to do and do number 14 here. So I'm going to move everything to the left. Oops. So I'm going to add 9. And I also know that 36 is 6 squared. Okay, so this is 6 squared to the power x minus 6 times 6x plus 9 equals to 0. Okay, so I added 9 to both sides, so it disappeared on the right. Okay, now 6 squared to the power x, I could actually write as 6 to the x squared. Okay, now if I let u equal 6 to the x, and I replace these 6 to the x's with u's, then my equation is going to become u squared minus 6 times u plus 9 equals 0. So now I have a quadratic equation in u. So I want two numbers that multiply to give 9, but add to give negative 6. So that's going to be negative 3 and negative 3. So I'm going to have u minus 3 times u minus 3. Or, if you prefer, u minus 3 squared. Okay, so that's going to be 0 exactly when u minus 3 is 0, which is when u equals 3. Okay, so now we're not done because now I have an exponential equation. So if u equals 3, that means that 6 to the x is actually equal to 3. Okay, so u was 6 to the x. So now I replace it back because I actually wanted to solve for x. Okay, now this is an exponential of the form that they can't be written in the same base. So what I'm going to do is take the ln of both sides. So ln of 6 to the x is equal to ln of 3. Okay, now I can bring the x down. So that's x times ln of 6 is equal to ln 3, which means that x is going to be ln 3 divided by ln 6, which is approximately 0.613 when you calculate it. Which I can plug in because my original equation was exponential. And I took lns of positive numbers. Okay, so that's definitely going to be the answer. Nothing bad happens. So that is my answer for this one. Okay, now it's possible because we had a perfect square here, we only got one equation in u, but it's possible that these numbers are different, and then you would have two equations in u and two exponential equations to solve. So just be prepared for that. But you can solve them in the same way. Okay, so that is solving a whole bunch of different exponential and log equations in different ways, depending on their form.